In the mark scheme for part A, they start with the left-hand side and obtain the right-hand side, but I just thought it'd be easier to do it the other way around, and it's an absolutely valid proof. If you're showing two things are equal, you can you can you can even start from the left-hand side, do a little bit, start from the right-hand side, do a little bit, and show that they're the same. So you could just expand them both. But I'm going to go from the right-hand side and get the left-hand side. And we're going to start the summation. So I'm going to let r equal 1, then I'm going to get f of 2 minus f of 1, and then add on, when I put 2 in, f of 4 minus f of 3, and so on. And so my last term will be f of 2n minus f of 2n minus 1. So what I want to do now is start writing them in this kind of form, and then I'll be able to write it as a single summation. So I could write the minus f1 as minus 1 to the 1 f1, and then f2 I could write as minus 1 squared f2, because that will mean it's still just f2. And we can continue in this way, minus 1 to the 3 f3, minus 1 to the 4 f4. In the last two terms, I'll have minus 1 to the 2n minus 1 times f of 2n minus 1 plus minus 1 to the 2n f of 2n. And then that means we can just bring it together. It will be the sum from r equals 1 to 2n of minus 1 to the r fr, because that is precisely what this summation is. And therefore I've shown that the right-hand side is the left-hand side. Of course, if you're doing it the other way around, you would start with the left-hand side, you'd expand it and get this, you'd then change it back to this and bring it together. So I don't know. I just felt like this way was a little bit simpler. Now we're asked to use the standard summation formulae to show that this is true. Note we've also got part A to help us along the way. Let's begin. So I've got the sum from r equals 1 to 2n of r times minus 1 to the r plus 2r, and I'm squaring it. So I'm going to write it, just to make it clear, as the same thing again. So now I'm timesing this double bracket together. We've got the r there, but let's deal with the double bracket. So I'm going to get minus 1 to the 2r, and then I'll get 2r times minus 1 to the r, but I'll get another one. So I'll actually get 4r minus 1 to the r. And then finally, I'm going to get my 4r squared. So this will become r to the minus 1 to the 2r. But the thing is, that is always even, so I can just get rid of it. Plus, now I can bring the 4 out of the next summation, but I cannot bring that minus 1 to the r out, so I'll get minus 1 to the r times r squared. So I've dealt with this part with this part. Now I've just got the 4r squared times r. So my final summation is going to be r equals 1 to 2n. Bring the 4 out, r cubed. Okay, the first and the third ones are pretty standard. So we have, let me write it up here. We have that the sum of r is equal to a half n plus 1 if I'm summing from r equals 1 to n. So this one here is going to equal a half times 2n times 2n plus 1. No, I'm not going to start expanding that, because in the final answer they've actually factorized out a 2n plus 1. So, and an n actually, and so I've got it perfectly. In fact, I will just do the half times the 2. So I've actually got n times 2n plus 1 here. Brilliant. And then let's just look at this one. So another formula. It's such a good formula. So when you do the sum of the cubes, you actually square the sum of the R1. So you get a quarter, sorry, you get a quarter n squared n plus 1 squared. That's how I remember it, just to square that one there. And then although, oh no, we're going to use it in a minute, the sum of r squared is a sixth n plus 1, 2n plus 1. Remember that one as well. Actually, I think these are given. Yeah, these two, the r squared and the r cubed are given. I think you have to remember that one there. Oh, I'm doing a smiley by it. Yeah, so make sure you know that one. It is actually an arithmetic series, so you could always derive it if you needed to. So over here, I'm going to get, well, it's 4 times a quarter, and then I've got n squared replaced by 2n squared. Actually, I don't want to rush it. Let's do a quarter. So 4 times a quarter, 2n squared, and it'll be 2n plus 1 squared. The 4 and the quarter cancel. This becomes 4n squared, and then 2n plus 1 squared. This just leaves this one, which is the most complicated one, and that minus 1 to the r is what makes it complicated, because sometimes we're going to have a positive quantity. When I put in 1, I'm going to, well, when I put in 1, I'm going to get a negative 1 squared. When I put in 2, I'm going to get a plus 2 squared. So we can now use our result from up here. Because we can't apply the formula as it is. Okay, so for me, this is, you can see it's basically the same, but f of r is r squared. It's identical otherwise. So that means it's going to become the sum from r equals 1 to n of f of 2r. So that will become 2r squared, because f of r is r squared. Then I'm minusing 2r minus 1 squared. And don't forget, I've also got a 4 there. Okay, that's a crucial sort of slightly unseen bit to this question. So now before we try and do any sort of summation, let's simplify things. I'm going to get 4r squared minus, then in brackets, 4r squared minus 4r plus 1. I can just, I'll do it on a new line, but you can just expand that bracket. 4r squared minus 4r squared plus 4r minus 1. So these cancel. And then I've got 16 times the sum from r equals 1 to n of r. Brilliant. And then I'll be minusing 4 times the sum from r equals 1 to n of 1. And I've just realized, yeah, I don't need that r squared one after all. Sorry, I thought I did need it to because we had it here, but we've managed to, because of the minus 1 to the r, we've managed to avoid it. Doesn't mean we shouldn't have written it down, just to practice it anyway. But we're going to go back to using the half n plus 1. So we've got 16 times the half n plus 1. And over here, if I'm summing up n lots of 1, it's just going to be 4n. This gives me 8n, there's meant to be a 1 there, 8n n plus 1 minus 4n, which is 8n. I don't quite have that 2n plus 1 at the moment, so I'm just going to keep going. 8n squared plus 8n minus 4n gives me 8n squared plus 4n. I can now factorize out a 4n, leaving me the 2n plus 1. Brilliant. Okay, so that means my summation, which I'm just going to say, where are we? I'm going to define it as S. So S is this n times 2n plus 1. oh, sorry, I've already forgotten what it was, n times 2n plus 1. Then I'm adding on this 4n times 2n plus 1. And then that third term was 4n squared, 2n plus 1 squared. Okay, worth just having the back of your mind like the answer. This is what we're trying to get. This is guiding us along the way. So the first thing I'm going to do is factorize out n times 2n plus 1. So I'm going to get 1, and then it'll be plus 4 plus, it will be 4n 2n plus 1. This gives 5 plus 8n squared plus 4n. Ah, we're there. Just rewrite it one last time, like this. Finally, we can use that result to hence evaluate this. Let me just bring it all down. And remember, if you got stuck with part B at any point, especially that minus 1 to the r, you can still do this final part. So I have this summation from 14 to 50. So the summation from r equals 14 to 50, well, that is going to be the sum from r equals 1 to 50. This gets it in the right form here. N would be 25. Then I'll be minusing the sum. Now, technically, I want 14 to 50, so I need to minus 1 to 13, but I can't, I need it to be double at the top. Remember, n has to be like an integer here. We can't go using 13 because it'd be 6.5. So I'm going to go and minus 1 to 14, and then I'm going to have to add on the term, the 14th term. That will sort it all out. So all I need to do now is sub values in. I'm the first term on the left is going to be this when n is 25. Oh yeah, this was n equals 7. So it will be 25 times 51 times 8 times 25 squared plus 4 times 25 plus 5. Okay, we'll work that out in a minute. Then I'm going to minus, it will be 7 times 15. I'm now just subbing 7 into here, times 8 times 7 squared plus 4 times 7 plus 5. And then finally, I just need to minus the 14th term. So I'm going to be putting r equals 14 into this one. So, sorry, what am I minusing? I'm adding 14 times minus 1 to the 14. Will that just become 1? Because it's even. Plus 2 times 14, that's going to be 28. Ooh, and then I'm squaring it. So just work these out really carefully, and you should get 6, but I'm not going to put it into my calculator like here, but I have already done it. 6508875 minus 44,625 for that second term, plus 11,774. And this ends up being 647,602,4, 6,476,024. And we've used our knowledge of summations to work this out. Pretty cool. Well done.